go. For the fifth time. Coplanar lines are non-coplanar. So these are lines that are not on the same plane. Like we're going to have a line on the ceiling and a line on the back wall in the classroom. Those are non-coplanar lines. That's what skew means. They're never going to intersect because they're not on the same line. So if I wanted to talk about two lines on this figure that were skew, an example would be like W to V back there and U to Q. Now I couldn't pick V down to, is that an R? R right there. Because those guys do intersect up at that point. And technically, that orange line I picked is on the back of the box too, right? So if I pick this line from V to R, which is on the back side of the box, it would be on the same plane as the orange line, technically. And I couldn't, we're talking about non-coplanar. They can't be on the same surface to be called skew, okay? So if you're just talking about like on a coordinate graph, and I've got two lines that are parallel, right? They're never going to intersect. Then they could intersect. They could just cross each other, however, or they could cross each other perpendicularly, right? And that is the only three kinds of line pairs that we would have on the same plane. So skew lines are like on a box. Always think about a box. If you talk the top, back corner of the box, edge of the box, and something off the front of the box that's not on the top, right? I can't take that top front corner like this, like HG and EF here. Sorry, HG and EF. Those are both on the back and the front of the box, but they're also both on the top plane. So they're coplanar. Skew lines are non-coplanar, is what I'm trying to get across there to you in a roundabout way. Okay, so these are example problems when it's asking you to name segments that are parallel or coplanar or skew. These are what they look like. Well, I'll do one with you and then I'll let you try two. So, name all segments that are parallel to AE. So if we look, here's AE. I'm going to color it purple. Okay. What else is parallel to AE? Well, on that left-hand side of the box, I could go back here and pick up HD, right? HD. Then I come back up to the front of the box and pick up F down to B. And then I could go over here to this end and the back and pick up G to C. Now, even though A to E and G to C are not on the same plane, they are parallel, because if I put a cross section in that box, that would be a plane they could fall upon. Does that make sense to you? Okay, so then it says give two examples of parallel planes. So if you're looking at a six-sided box, how many pairs of parallel planes are on the box? 3. Thank you. The top and the bottom would be parallel to each other. The left and the right side, and the front and the back. So when you have a picture like this that starts asking you for stuff, just remember that this is just a box, just a six-sided box, a cube, if you want to go there with it, okay? And then when you write this out, I'm just going to do two of them. Remember that planes have to be named with 3 letters, okay? So like E, F, H, and that's plane. You got to write that word out. There's no symbol for it. E, F, H. That's the top. And then if I did the bottom, I could do A, B, D. That'd be the top and the bottom of the box. Let's do the front and the back as an example. So A over to B up to, I wrote on that, is that an F? A, B, F? That's the front. And you gotta, I know, you gotta write out that word plane because there's no symbol for it. Sometimes you'll see this drawn. Well, looks like a little parallelogram, but you don't know if that means parallelogram or means plane, so it's not advised to use it. But if I go from the front to the back of the box now, what can I do? HGC, HGD, whatever. 3 of the 4 points. Okay? So now, I'm going to look at G to H. It says I want to name all the segments that are skewed to that line back there, G to H. Remember, it can't be on the plane with G to H. It cannot intersect G to H in any way. So that should automatically tell you that that is on the top and the back of the box, which takes all of those line segments out of play for the answer to this question. Okay? So I cannot do the back of the box at all back here. So that takes this line out and this line out. I can't do anything across the top to be skewed to that. So that only leaves me A up to E here. I got A over to B. B back to C. And then E to, no, that's an F, I'm sorry, F to B. And I got one more from A back to D. All of those are not on the same plane and would not intersect HG. So we want to name all of the segments that are parallel to JK. So I'm just going to take this little color right here and look. There's JK. Parallel to JK means it has to be opposite of it, first of all. It could be on the same, it has to be on the same plane, or I have to be able to put it on a plane between two things, right? So the only thing there is OP. Then this second question says, name all the segments that are parallel to NS. Well, here's NS. Now that's like from the front to the back of the box. Okay? There are 5 of those that are parallel. You've got M to R, L to Q, K to P, and J to O. All those line segments are parallel. Then this next one says, name a plane parallel to JKL. Well, here's JKL. It's the front of the box right here. I'm going to just color it for you a little bit. What plane is parallel to that? The back of the box. Yeah, and any 3 letters off there. SRO, SRQ, POR, POS, whatever you want to name it. Any 3 letters off there names that plane in the back. Okay? Then the last one says, name 4 segments that are skewed to RQ. Find another car. So, here's RQ. Let's talk about what is not skewed to that. First of all, anything on the back of the box, not skewed. So the back of the box is out. You can't name anything off the back of the box, any line segment off the back of the box. You can't, RQ is on this top right hand side here. You can't name anything off of that side of the box. Okay? But look at all the stuff that's left now. If it's skew, it could come off of the bottom of the box that doesn't touch the back. So what's there? JK. That's easy. 4. We're going to do 4. How about this side of the box right here? LKPQ. what doesn't touch the back of the box or the top of the bunch? LK is skew because it's going this way, up and down, and it's just going to touch at that corner, right? But remember, we just talked about that. L and K, this is what that RQ is back here like this, and LK is out here in front of it, like this. Well, all right, can't get that on there. Okay, and then two more. How about NM? And how about NJ? There's more. I just did those four. If you have one you want to ask me about,
What about
JN? J, well, NJ and JN are the same thing.
How is SOR when there's a launch connected over R?
Say it again. Ask the question again, Danielle.
How is SOR when and there's no line connected over R? I got OPQ.
Okay, you were supposed to name segments. OPQ, it would be
I'm talking about C.
on C.
I don't understand D at all. Just not gonna.
You still got it right. She said name
Any three.
But I'm trying to figure out how she got SOR when ain't no.
I just picked
Just pick any three.
any 3 points off the back for this one. You're on this one.
So it don't have to be connected at all.
Does not have to be the same 3 points. Does not have to be connected at all. Just any 3 points. Name a plane.
I think you're still right.
D.
Here, NM. Sorry. I know I'm writing in colors, so that's going to make it hard. And that's NM. N to M. Look. That's not going to be parallel to RQ. It's not going to be.
So skew is not parallel.
What?
Skew is when it's not parallel.
Skew is when it won't intersect. Okay? They're not parallel, but they won't intersect. So I can't use ML, can I? Look at ML. I can't use it because it is parallel to RQ. Okay, so they can't be parallel and they won't intersect. They're called skew. They have to be on separate planes. Okay?
So,
All right.
You know how to do that.
All right. So the transversal, a line that intersects 2 or more lines. If a straight line cuts across 2 or more lines, it's called a transversal. Oh, we're not talking anything about parallelism or anything. If it goes across 2 or more other lines, it is a transversal. So in this example, we have line L and M. Here, line L and M. The transversal is line T. That is a little cursive lowercase t up there. So this is the transversal. All right, continuing on with our life here. So it says that we may sometimes hear or read the phrase parallel segments. To make sure there is no confusion, let's define that phrase. 2 segments are parallel if the lines containing them are parallel. Okay? So these 2 lines are parallel. These 2 lines are not parallel. So if I took this little segment here and this little segment here and this, just because those 2 pieces of those lines don't cross, don't mean they wouldn't eventually cross. Okay? So those are non-parallel. And the same thing here, obviously, these 2 segments cross, so those are non-parallel. And to define a transversal a little better, it's a line that intersects 2 or more coplanar lines at different points. So here's my two coplanar lines. This transversal right here comes down here and goes 1, 2, and goes on. It intersects both those lines. Okay? Then we talk about interior and exterior. And let me color code this a little bit. So interior angles just means everything in here between the two lines that the transversal is intersecting. Those four angles in there. And exterior, right here, means it's outside. So it'd be these two angles and these two angles. When those two lines are crossed by transversal, there are four angles that appear there. 1, 2, 3, 4, 5, 6, 7, 8. 8 angles, 4 at each intersection, right? So 1, 2, 7, and 8 are all exterior. And then 3, 4, 5, and 6 are all interior between the two lines, outside the two lines. And if that helps you to write between and outside, interior in the house, exterior outside the house. Okay, going on to a couple more notes. I know this is a long lesson. So we start getting some special angles. Now, I'm sure at some point in your life you have studied these special angles. If not, I'm sorry, because you should have. But we're not talking about the lines have to be, we're just talking about when two lines, any two lines are crossed by a third line, another line. Here's what happens. First of all, I get some alternate interior angles. The alternate interior angles are on opposite sides of the transversal. So that's one thing you can, alternate means opposite sides of the transversal. And then interior means between the two lines that are being crossed, right? So I'm going to color this purple right through here, just haze it in purple. That's the interior of that. So between the lines, opposite sides. So that's 4 and 6, and then the other pair here is 3 and 5. Okay? We're just going to keep going with this concept. Same side. Oh my gosh. What do you think it's same side of what? Same side of the transversal, where everything is in relationship to the transversal. So same side of the transversal here would be, and these are interior, inside, 4 and 5. And then the other pair is on the right hand side, 5 and 6. Same side. We're just talking about their position today. Okay? The next one is corresponding angles. So I have these 2 points that the 2 lines cross this transversal. Corresponding angles have the same position. That's all they have. So like 1 and 5, they're above and to the left. See that? And then I can look at 2 and 6. There's 2, here's 6. They just hold the same position. Then when I look at 4, I look at its corresponding angle would be 8, because that's to the left and below that parallel line. This one is to the left of the transversal and below the parallel line. And the only other thing left then is 3 and 7. They're both to the right and below the intersection. Okay? Those are called corresponding angles. Now, just like we had alternate interior angle pairs up here, we have some alternate exterior angles. Alternate what? Alternate always has to do with transversal. Same side as or alternate sides. Okay? So this up here was alternate interior. This down here talks about exterior angles, which are outside, out here. Okay? And if I start talking about angle pairs here, I'm pick 2 and 8. Alternate sides of the transversal, outside the parallel lines. And then I can come back and pick 1 and 7 as opposite exterior angles. So, we've got some angles that are formed by transversal. And here is a picture of two lines that are crossed by a transversal. I'm going to try to color code this for you in this video. So corresponding angles are angles on the same side of the transversal and in the same position. That would be angle 1 and angle 5. They're both above the parallel line and to the left of that intersection.
Is that a plus sign?
It's an and sign. Sorry. And.
Come on.
They're just corresponding. That's all they are. They have a corresponding position. What's their position? They're above the parallel line and to the left of the transversal. Above the parallel line to the left of the transversal. So what if I go above the parallel line and to the right of the transversal? I'd get to angle 2. What corresponds with it? 6. Angle 2 and 6. Angle 2 and angle 6 are corresponding. They have corresponding positions.
4 and 8.
4 and 8.
3 and 7.
4 and 8 are corresponding, and 3 and 7 are corresponding.
I'll tell you that I don't understand this. I was just doing what you did.
Well, that's how you learn. You mock what I do. Let's look at the next one. Alternate interior angles. Alternate the transversal. That means opposite sides of the transversal.
So 4 and 6. So 1 and 3.
4 and interior.
4 and 6.
4 and 6. That's the first set. 4 and 6.
3 and 4.
And 3 and not 4.
I mean 5, my bad.
5. Yeah. Okay. So angle 4 and angle 6 and angle 3 and angle 5. Those are all on opposite sides of the transversal and inside the lines. All right, next set.
This one would be 2 and 8.
2 and 8. That's one for alternate exterior. We're looking at 2 and 8. And angle 1 and angle 7. So these last two words, the word consecutive means same side.
It's 4 and 5.
4 and 5.
On interior angles and 3 and 6. And then on the exterior angles.
And then when we go, hold on just a minute. Same side interior, stay between the two lines, between the parallel lines or the two lines, And on same side of the transversal, 4, 6, or 4 and 5, I'm sorry, 3 and 6. Now we're going to go to consecutive exterior,
1 and 8. 1 and 8 and 27.
1 and 8, and 2 and 7. Sorry, I keep getting that crosswise. I don't mean to. Alright, so let's look at one real quick at this example 3, then you can try 4 on your own.
Alternate exterior angles.
So it says, name the type of angle relationship. If no relationship exists, write none. So we're looking at angle 1 and angle 8. Those are both exterior angles, and they're on opposite sides or alternate sides. So they're alternate exterior.
And then B is alternate interior.
Make that a little darker so you can see it, baby. Okay, the next one says 2 and 3. 2 and 3.
That's consecutive interior.
Those are consecutive. Look, let's first of all, here's 2 lines. This is the transversal. Right here. This one line going across there. So 2 and 3 are same side or consecutive interior. And I don't care if you do some abbreviating at that point. Then we're looking at 5 and 7. 5 and 7 are both to the left of the parallel lines and below the transversal.
Corresponding angle.
Corresponding. Then we're looking at 2 and 7. 2 and 7 are both interior, the 2 lines,
Alternate interior.
and alternate sides. There you go. You're getting this. You can do this. You got to be able to identify their location before you can start putting the math to that location. There is math for each of these locations. Then 1 and 3.
Would they be corresponding?
Corresponding, because those are both to the left and above. So those are corresponding. And how about 5 and 8?
Consecutive exterior.
They are on the same side of the transversal, and they are both exterior, so they are consecutive exterior. Now, one of the reasons that the word consecutive and same side is put up here together is because sometimes you'll just see that as SSEXT. I don't know why they don't get it together and do the same, but they might call it same side. Depends on who the publisher is in the book. Okay? Depends on where the worksheet comes from or the question. If it's a 7th grade question, it's going to be same side. You understand what I'm saying? If it's a high school level question, it's probably going to say consecutive. Because they want you to know that those mean the same thing. Consecutive means I go down the same side of the hall. We all walk down the right, let's say. That'd be our consecutive side.
Oh, okay. So first one is corresponding.
All right. Try that next problem down there.